universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hello, everybody. Big doings. I gotta tell you, I want to say hi, Tara. How are you?
Hi, Mark. Hi, everyone. How are you all? How are you? I'm doing good.
Oh, yeah, no. Mm-hmm. Yeah, it's good. One of the things that you guys don't know about her, okay, she has tortoises.
Mm-hmm. Tortoises, yes. Two of them.
Hank and Bruiser, if I recall.
Mm-hmm.
Yeah, I've seen these tortoises, and you think of the Galapagos tortoise. They're like 1,000 pounds a piece. No, there are smaller ones. This one's I think these are desert tortoises. Is that
They're African desert sulcatas.
Okay.
So yeah.
If you're wondering.
Yes. And they're about 100 pounds a piece right now, which is enough to not be able to lift them anymore. But
yeah, and
they're awesome.
Yeah, you know what? She does the most incredible stuff for her animals. She's a real animal person. She has birds.
Love them.
She has dogs, and cats, I think, too.
And bunnies.
And bunnies, yeah. And that's and tortoises, of course. So
yeah.
5.
And they're all rescues as well. So
which you can see that she's doing incredible work over there. Show her the love. She's incredible. Yeah, so I visited their rescue home.
Zoo.
And that's there you go, rescue zoo. And I met Hank and Bruiser, and it's funny watching these tortoises plod their way along on the lawn. They go thunk, thunk, thunk. But when they really want to move, they go thunk, 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 thunk.
Run!
Yeah, and the tortoise is thinking, I'm going to win the race. And he's going like half a mile an hour. Wow, that's fast for a tortoise. So cool. But
they're cool.
Yeah. But welcome, Tara, tonight to SkyTour LiveStreams. SkyTour Radio. It's not SkyTour LiveStream, but we are going to talk about that tonight too.
Awesome.
And when we talk about what we do here, you guys, most of you know. Okay, I see in the chat. I see a lot of people that we know. But what we call SkyTour LiveStream, which Tara's a part of, as is Marianne Robb. Okay. SkyTour LiveStream is a clear night journey into the cosmos. We bring you the universe live in real time. And we show you objects and images of objects that we take with our telescopes live. And you literally watch it happen right before you. You see live, you'll see satellites going through the view sometimes, and a lot of times now, especially today. And, we have these weekly gorgeous images that are provided, very, very high res stuff that we make for our Patreon subscribers. And we have chat and people in the chat can ask questions. And, I'm an astronomer. That's what I went to school for. So I just can't let a question go unanswered. I try to answer every one.
Great.
Yeah, I know, right? You imagine that's pretty hard during things like a lunar eclipse where we have 5,000 people watching at once.
Well, they all probably have similar questions, though.
And the chat's going like this. It's like 7 seconds ago and about 400 chats up there. Somebody asked a question. Luckily, we have these great moderators, including Isabella, who's here in the chat, and other folks that are very much in tune and keep on top of things. And tonight we're going to actually preview something Isabella has been championing in the beginning, and I'll show you this. We're going to talk about it and show you a sample. In short, we're going to have an Apple and an Android app for SkyTour LiveStream.
Awesome.
And Isabella has actually brought that to fruition. And we're getting very, very close. We're in testing right now. Now, originally, this was started by Robin Curtis, who was a volunteer with SkyTour LiveStream, and she started to put together a spreadsheet. I had mentioned many times, boy, I want to get a list of all of our data. I want to get our data into a database. And Robin just quietly did it in the background and finally unveiled it one day. It's like, whoa. And then Isabel comes along and says, I think I can work with that too and do even more. And she did. She actually completed the list right up to the other day. Okay, so we have data from 2021, 2022, 2023, and 2024 in there. That's 4 years of data. Well, starting on the fourth year of data. And it's updated dynamically. So when you're looking at it, you can all of a sudden you get the latest and greatest app, which has more objects in it. You can search for different objects, and we're going to preview this later, so you'll see it a little bit. Also tonight, we're going to talk about, I'm going to show you actually a talk that I give around the country that has been very well received, and I humbly ask that you enjoy this when we do this, because I talk about UFOs and how they may actually travel, and that methodology by which they travel, okay, is something that is not woo-woo. It's not out there in the ether, and maybe they do this. This is something that actually exists within, I'll call it near physics, the physics that's to come, right? It's not here yet, but it's something that could potentially make us an interstellar race.
Wow.
Once it happens. It's really cool. So we'll talk about that. So if you're interested in what we do in general with SkyTour LiveStream, a little bit about that. We have SkyTour Sonoran, which is the Sonoran Observatory. That's known as the Maudlin Hain Observatory. And then we have SkyTour Benson, which is in Benson, Arizona. It doesn't have a name yet, but it's probably going to have a plaque in it for one of our biggest donors. And he knows who he is,
I know who he is.
Yes, you do. And then out here in the East Coast, we're going to have SkyTour East. We're going to have a third observatory. And we already have the equipment for SkyTour Benson. And we're going to be installing that over the next few months here. And SkyTour East is actually going to be a very different observatory. It's going to be a solar observatory. Cool. During the day, we're going to look at the sun all day long. Every day. It'll be streamed all day long.
I thought we weren't supposed to look at the sun, Mark. I'm confused. Right. Well, with certain telescopes, you can, and you can see those beautiful prominences that are normally only available in an eclipse. Wow.
You're going to see them, and you're going to see the surface, the rounded front of that surface of the sun, and where these prominences that come off the edge of the sun, where they're coming out towards you from the sun, they look like black snaky lines, sometimes broader as they climb and they spread a little bit. Wow. When they do it on the edge, you see them on the edge, but when they're doing it here, what do you see? You see them cooling off a little as they leave the surface of the sun, so they look dark. See? So that's going to be available on any clear day on the East Coast as well. So it's going to be pretty cool. And I also want to say happy Cinco de Mayo to all those who are interested in Cinco de Mayo. Dun, dun, dun,
I got my little maracas. Yeah.
There you go. So, check us out. We're at SkyTourLive.org. That is a location or a place where we are always available. You can always find us there. And I'm trying to see if we can, if we have our banner for SkyTour Live or SkyTour LiveStream. I don't see it here. Yeah, it's. I guess I gotta select the right thing here, but it doesn't matter. In any case,
is that it?
I would say that is. Where'd you find that?
In the banners.
Yeah, I thought I said it. I see dead air, rare, STP. I didn't see it. I have SkyTour Radio. Was that the one?
That's the one. That's where it is.
Oh yeah, you're right. Never mind.
But there you go. That's where you can go. SkyTourLive.com.
Yeah, SkyTourLive.com or SkyTourLive.org. That's our portal. If you go to the upper left in SkyTourLive.com, it'll take you to SkyTour LiveStream, which is our live stream on YouTube. And if you go to the other side, other side. Then that takes you to our Patreon. And if you go and look in a little bit further to that side, you'll actually see, thank you, you'll actually see that we have a shop now called SkyTour Shop, which is a shop that we have on Etsy. And it's actually pretty cool, really cool. So I want to thank you guys. Also, if you get a chance, check out uappd.com. This is Marianne Robb and Dave Rich's unidentified anomalous phenomena as seen by the police departments around the country, PD. So check out uappd.com. They did not pay me to make this announcement. I did it for free. And so Marianne is probably saying, you better do that. No, I'm just kidding. She wouldn't do that. So anyway, moving forward tonight, I want to take you into a talk I've done, and it's going to be this one here. This is called From Here to There and Back, How UFOs Travel. Now, it's not going to be delivered in an authoritative manner like I know everything, because I certainly don't. Tara often tells me I don't know everything, and as much as I've denied it, she's been right. But the truth is, I want to take you through a little bit of the history on our planet of looking up into the sky and seeing things, and then we're going to move on outward, and then we're going to actually look at ways in which Hollywood has affected the question of UFOs and UAP. We're going to look at the way that the military has affected UAP and so forth. It's not going to be dry. It's going to be funny because Tara's going to make it funny. She's going to do all the funny
pressure
stuff. See, that's funny. Anyway, so in general, when we look at stuff, when we look at this concept, we have to kind of look back at the Earth and look back at the early astronomy.
Right.
In the past, okay, we've had early people have chronicled the skies from 17,000-year-old cave paintings to 1,000-year-old Babylonian tablets. And they chronicled constellations, positions in the sky, where things were. And that was something that they did. It was just part of their nature, right? And the ancient Greeks did that as well.
Oh, the Antikythera device.
You know this object.
I love that object. It's fascinating. See? It's fascinating.
Right. This thing, this object right here would show you the positions or calculate the positions of stars and planets in the sky. In the modern world, we'd call it an astrolabe, and it would show you these positions. And it had such a complex machinery inside. Extremely complex for the time. You can just imagine someone like Pythagoras, a famous philosopher, who was also an astronomer. Okay, you could imagine him using this. It's just incredible. In fact, in some way, and I say this half meaningfully, there may be some remnants of his DNA on here somewhere. Maybe within a fingerprint underneath all this crud up on the brass
barnacles.
Yeah, so I think it'd be pretty cool if that was the case, But so the ancient Greeks did this as well, and so we've always looked up. We've always looked at the sky, and the Chinese did as well. And at one point, they saw this new star in the sky in 1054 AD, and in 1054, this new star was bright in the sky. You could see it during the day. Okay.
That's bright.
Yeah, very bright. Yeah, and you can see the planet Venus, for instance, during the day. And if you know where to look, you can see it. It's just barely on the edge of your visibility. But if you look away and go back, I lost it. Then you got to search for it again. Well, this was nothing you had to search for. You saw the sun and you saw this other object in the sky. It was definitely there. And, this was something they didn't understand. It was just a new star in the sky. Nowadays, we understand this because we understand it to be this. This is the Crab Nebula. It's a supernova remnant. And this is a Hubble Space Telescope image. In the center of this is a pulsar. It's the remains of the star, a neutron star that's rapidly rotating. And it has these lighthouse beacons of hot radiation that are coming out, and they flash by the Earth every time it goes around. Okay, you know how many times it flashes at us per second? 33.
33. Okay, that's a lot.
Times. And yeah, and the pulsar, this neutron star, is the size of Manhattan Island. So imagine something like that moving 33 times per second and spinning that fast. Now, you would say, well, the gravity, how could that hold it together? It should fly apart. You'd think so, except that the neutron star is extremely dense and compact, because it's taken a stellar core and compressed it down to something the size of an island, Manhattan Island. So that density leads to very, very high gravitational forces that are holding it together. And on top of that, these forces are responsible for, in part, generating a lot of the heat inside the neutron star. And so the rapid spin of this thing is just depending on how the thing collapsed. It could have, when the supernova went off, it could have hit the core of the star differentially, so that one side gets hit more than the other. So it started this rapid spin. And you might think that's pretty fast, but it's not the fastest spinner out there for a pulsar. The fastest is over 700 times per second.
That seems impossible.
It does seem impossible, but that's how fast it's actually spinning. It's rotating on its axis once every 700th of a second. And that's actually 720 or 715, you know. I mean, you measure its spin rate by a frequency rather than revolutions per second. It's a frequency that you have to use because that makes more sense. So anyway, these things exist out there. And so the Chinese astronomers saw this. And so clearly we embarked on a journey to get more information, look at the stars a little bit more, and see what what we can see. And that became the quest of William Herschel, who in the 1700s created a 43-inch telescope. And that's what you see there is the telescope. And this is Herschel standing on this little on this little platform, which would slide up and down on here. Okay, remember, we didn't have any fancy motors. Everything was pulleys and ropes. So he had to pull himself up, and the telescope was moved by pulleys and ropes. This was a giant turntable. It wasn't very accurate, and it didn't follow the stars. Someone had to constantly be pushing it, you know, and moving this telescope to actually follow and look at the stars. And so he couldn't look really straight up. That's the thing. But he could look at a whole swath of sky all the way around. And Herschel discovered a great many of the objects that we see in the sky today. Okay, and including the planet Uranus. So really fancy stuff. Now, after Herschel and his 43-inch telescope, which, by the way, the mirror wasn't made of glass. It was polished and silvered because they didn't have that process.
Oh, wow.
It was called speculum metal. It was a metal. Okay, and the metal was called speculum, which is an unfortunate name, but that's what it was. And they had to shine it more than they had to polish it actually multiple times per day to keep it from tarnishing, because it tarnished almost immediately.
Oh my goodness.
Yeah.
That's a lot of work to be an astronomer in the 1700s.
That's correct. And then when Lowell Observatory was built, I'm just selective telescopes. These aren't the only ones. They had a 24-inch diameter lens, and that leads to this long tube. With a 24-inch diameter lens, that leads to a long tube, and the eyepiece is down here. Well, wait a minute. You can't get to the eyepiece. So how in the world do you see through it? Well, in some of these telescopes, you actually had the whole floor moving up and down to meet the telescope. Oh, this one, I believe, had a ladder that you'd go up in the middle of dark night and look through the telescope eyepiece. I worked in a similar observatory with a 20-inch refractor, so the building was a little bit smaller, but the whole floor was an elevator that moved up and down to meet the telescope. And I just loved looking at things that were shallow on the horizon, because then it was like 2 stories above me, and I would run the elevator, and the whole floor would go up 2 stories. You know, you feel like you feel the pressure change. No, you don't feel pressure, but it's really neat. So this was the next generation for these wonderful telescopes, and they're classics now. And then we had the Hale telescope at Mount Palomar. This is the mount here. This U-shaped thing is actually the mount.
Huge.
Okay? And the telescope is this here, this long barrel. And see that round opening?
Yeah.
That's called the observer's cage. The eyepiece is in here. You got in here and you rode around with this. You rode around with this. Yeah, you rode, and you had to be really still, because if you moved around, the telescope would do this and your image would get ruined that you were taking for 2 hours. You had to sit stock still. Okay, so not so fun, especially when it was 15 degrees out.
Yeah, it still would be fun.
I know. Now it's all electronic, and you don't no longer have to go in here except for maintenance. All right, so that telescope was a tremendous leap in technology. And then we had these much later on, the 33-foot basically Keck telescopes. This pair, 10 millimeter diameter hexagonal lenses. Look at the hexagonal mirrors here.
Yeah, you can see
really
them.
Cool. Yeah, and those were a great boon to astronomy. But then eventually we had to get out into space. So what we ended up doing was creating the Spitzer Space Telescope. This guy was able to show us things in the infrared for the first time.
Ooh, pretty.
Because you can't do infrared on the ground because the sky molecules and the clouds block infrared very quickly and very easily. So it doesn't reach the ground in copious amounts. An image like this would only look a shadow of what you see here in the infrared. It would be very, very difficult to see anything. So Spitzer looked at the universe with different eyes. The Hubble came along, and it did the same thing, but it looked at it with the eyeballs of a human, and we were able to see. I know this is moving. Okay. Yeah.
We're in space. Oh my gosh.
Right. And then we have, this is a visible light shot of the Eagle Nebula.
Yeah.
Messier 16. And that's invisible. And then Hubble also has infrared sensors. So it can actually see in the infrared. And this is what Hubble saw in the infrared. That's not bad. Okay.
Is that all dust?
Yes, in fact, that's all dust in here. This is all dust you're looking at here. And the reason that there's stalks like this is because there's a bright hot cluster up here, and the starlight is literally eroding the gas and dust around these concentrations. There's a concentration here, concentration here, concentration here. And these areas are denser, so they are resistant to erosion by starlight. But the stuff in between was not, and the stuff behind it is protected by these dense areas here. So it literally pushes away all the dust and gas. And this will eventually get eroded too. It just hasn't yet. Okay?
That's cool.
Yeah. But now
it's like a hand reaching out.
Oh, it actually does. Here's the thumb. And the bony pinky. Oh, yeah. It looks like it's doing this. Oh, you're absolutely right. That is so cool.
Weird.
Since you said that, now I see it. But notice this. This is visible light. This is infrared. What's the difference?
The heat? Is it?
Yes, that's correct. We're looking at the thermal emission. But what's the difference in the objects in this image?
Well, you see more with infrared, obviously. Or not more, you see the stars.
Yes, and these are stars that are hidden by dust that is in here that you just don't see. The dust is in here. You don't see it. It's here, and it's blocking all these other stars. Look at the difference.
Wow.
Nothing changed here. These stars are still here. They're just invisible. Okay, so that's what happened there.
Neat.
And so Hubble was great. And then we started saying, but wait, now that we can get into space, let's look for other worlds. And that's where the Kepler Space Telescope came along. And that was a telescope that was launched in 2009. And it found many planets out there. And it just found so many. It's actually over 5,000 now.
Wow.
And of those, and that's, by the way, that's in a small area the size of your fist extended. Okay, if you extend your fist at arm's reach and you look over your head in the sky, the size of your fist on the sky is where all these planets were found.
That's incredible.
It was just a small range of space. Yeah. Yeah. And so 20% of those could be habitable zone worlds. Earth is a habitable zone world. Hey, that could be ours. That could be like, that could be, that could be exactly what we're looking for.
Yeah. I have a question for you. So the closest one is that 12 light years away?
4.3 light years away. That's the Proxima Centauri, Alpha Centauri system.
So they're looks like they're finding new ones all the time. Do you think they'll find any that are closer to us than that one? Or
Well, that star is that's the
Mhm.
closest star system to us.
So about
So
the
if
same, huh?
anything, well, no, if anything, they can
Maybe.
find more planets around Proxima, which is
Wow.
the third component in this 3-star system. You have two stars kind of like the sun, and then way out here you have Proxima, and Proxima is orbiting these other 2 stars. All
Oh,
right, and it's around Proxima where we found at least 1 or 2 planets. Okay, so far. So, and that's just the nearest. And our techniques are such that we don't need to look at the nearest star systems to find planets. We can be looking thousands of light years away
it's
to find other
incredible.
planets. Yeah. Okay. So
Cool.
we found a lot, and now the Transiting Exoplanet Survey Satellite test, which has concluded its mission, found a whole bunch more, and it looked at the sky a little differently as we go into space again. Okay, and TESS, okay, it had a different way of looking at the sky. All right, what it did was it looked at a 24-degree wide by 96-degree field. Right, so there's the celestial sphere here on the right. Okay, and in that celestial sphere, this much of it was being looked at one time.
Wow.
Now the Kepler Space Telescope was like a pencil. It looked at one star at a time, one star, one star,
Wow.
one star. This was looking at thousands of stars at a time, and it found a great number of candidates. So this is the type of thing that we're going to pursue more of. And of course, we have the James Webb. It sees more of the infrared light, the light that's out beyond the red end of the spectrum, than ever before in history.
Wow.
And it really is incredible. This was the first light image it took. Okay.
Beautiful.
1, 2, 3, 4, 5, 6, because it's a 6-sided mirrors, kind of like the Keck telescope, 6-sided mirrors making up the array. And there's like 18 of them. And here's the difference in resolution.
Wow.
This is the WISE, the Wide Infrared Survey Explorer. Okay, on the left, that had a 1.5-foot diameter mirror, so only about 18-inch diameter mirror.
Hmm.
Spitzer had a 3-foot diameter mirror, so that's a little bigger. And so you could see more detail in the same field. Look what this 21-foot diameter mirror now shows. The James Webb shows the same region with way more detail than this middle picture.
It's
And this
beautiful.
we used to consider this really detailed. But now look at that. Ah! It's incredible.
It is.
Yeah. And we're using it also to characterize or figure out what atmospheres of exoplanets have in them. And one particular element, a compound rather, that has been found, once confirmed, could show that the James Webb Space Telescope found life on another world. And that's a compound called dimethyl sulfide. Dimethyl sulfide is something you all smelled before. You just don't know it. And it smells awful. And what is it? When the tide goes out, that smell you smell by the ocean, you're like, oh man, it stink. That's dimethyl sulfide. Okay. And where does that stink come from? Only one source on planet Earth, and that's life.
Oh,
Life makes that smell. So that's dimethyl sulfide is the thing. So remember the Hubble. These are the Hubble images of these are also called the pillars of creation, if you recall. All right. And this is in the infrared. Now let's take a look at the James Webb's version.
Ooh.
There's your hand.
Wow. Yes, you can see it.
There's your thumb,
Mhm.
the forefinger. It's like ET's finger. Home. You know.
That's beautiful.
Yeah. Look at all the
Wow.
stars. Look at this stuff. You can see how the starlight from out there, or actually out there in this image, has really shaped these pillars. Okay. And that's really impressive. Yeah. That's pretty cool.
It still gives me the optical illusion, though, that the pillars are coming out versus being blown away, being driven from out in, if that makes sense.
Now say it again, because I want to understand.
It looks like they're moving up and out versus the starlight moving down. Way? Yes, it looks like they're.
Oh, it looks like they're speeding this way, like that.
But they're eroding the opposite direction.
That's correct.
And that's the optical illusion that I always get stuck on.
Keep in mind that every object in the universe is moving in its own direction. Okay. Sometimes in a cluster of stars, all the stars are moving more or less in the same direction in a cluster. Okay. So too are the cluster of stars in the Eagle Nebula, this location. They're all moving in a similar direction. They're not moving in every which way. So they're all moving in the same direction. And so this dust cloud, if associated with the nebula itself is moving in a particular direction. So it's also going somewhere. It's possible that it's racing that way. I don't know. I have to check, but it might be racing that way. So there's a lot going on there. But this is how the James Webb has kicked it up a notch for us. Look at all that. Look at
do
this
they
detail.
have their own color palette as well, or is that all?
Yes, this is
infrared color.
Yeah, this is a false color image, because if you looked at infrared energy, you can't see it with your eyes. So we have to transpose it to something you can see. And these are the colors selected for the data. Okay, this data corresponds to the gas and dust. Okay, and the stars look the color they do, and of course the space around them is like blue in this rendering. So yeah, but there's so much detail in this image, you just can't imagine. Wow,
you could just stare at it forever.
Yeah, I mean, we can go forever. See, like, look at all the way down here. Oh, look, now it's a dinosaur. Here's its open mouth, the Tyrannosaurus. The eye is right here. There's a little tiny hands. Okay. Okay, and down here, here's the legs. Here's the feet of the Tyrannosaurus. We'll call this look. It even has a joint for a knee, a base, and a foot. Look at that. It's a Tyrannosaurus Rex nebula.
It is. I see it now.
That's right. Yeah,
brilliant.
And this is fire because it's falling into a volcano.
It's just beautiful.
We could go on and on. Yeah, you're right. So now that we're looking for planets, you've got to wonder. If the James Webb is this close to potentially finding life, is it possible that our government might actually try to suggest that life in the universe might be out there and ease us into the possibilities? Is that possible? And that's the question. So we ask, all right, what role do movies play in this arena? Do they play any role? And I guess we'd have to look and say, well, we remember this movie. This movie was called The Day the Earth Stood Still. And this was Klaatu, and the robot was the big robot named Gort, G-O-R-T. And this movie portrayed a sense of foreboding. We had to be careful not to destroy ourselves. We're entering the nuclear age. We had to be really careful. So it portrayed that we would have to be very careful if we expected to get into the galactic community, right? All right. So that was The Day the Earth Stood Still. So not a overall bad message, right?
No, but look at the saucer shape. Typical saucer shape.
That's right. And we're going to talk about that a little later as to why saucer shapes were saucer shapes and still are. Yeah. Then, of course, we had the xenomorph, Alien. And this was a construct to simply tell you stay home and hide. Okay? Stay home and hide. This alien would send its jaw into your brain and kill you. That's what it was. That's its job, to kill you. I don't know what that was about, but that's what it did. Okay, so that was Alien. So it was a sense of evil lurks out there, being messaged by this movie. Remember the Nostromo was out there looking for the aliens, went to their home planet. Stay away from them, you idiots! And of course, they didn't.
And the government's protecting it.
Of course, that's exactly right. The government was actually behind it. Okay. And then, of course, we had this movie. Do you remember this movie?
Yes, that's starts with a P.
What is it? Does.
Prometheus.
Yes, you got it. Prometheus. And these guys were called the engineers, and they were about 10 feet tall. And the purpose of the engineers was that they actually created humans, and they actually engineered life on our planet. They felt it was a dismal failure. And in Prometheus, the idea was that they were going to wipe all life off of our planet.
Yeah.
Okay. And the humans said, nah, we like it here. And so that's what the movie's about, without giving too much away. Really cool. So Prometheus was great. And then we had this movie.
Aw.
Yeah.
Aw.
And what was this?
E.T. That was like one of the first ones too. And when that
Right.
came out, that was just incredible. There's nothing like it before then. Nothing like it before. It's kind of seems not hokey, but it's it's Hollywood, but it's pretty cool.
Yeah, agreed. Like E.T. phone home. Remember that?
Yes.
Yeah. I like that. Elliot. And then the light that would form on the end of his finger,
Very creative.
Yeah. They would form a light on the end of his finger like a space booger. I mean, it was really cool,
Space booger?
I liked E.T. I saw it many times because it was just, and this was a movie of, we are not important. This is a movie saying we have cute aliens that we can take care of, and it's a sign of hope for humanity through the eyes of a child. An alien was saved to go home with its family. I mean, a nice message. It was a very, very nice Spielbergian message, right? Okay.
Yes.
And then we had this one.
Ruh-roh.
Yeah, not so nice of a message here. This was Independence Day.
That's a cool scene, though, when all that fire breaks out.
Yeah, and when they actually blow up the Empire State Building and go, and of course the White House, because why not?
Why not?
Okay, yeah, because of course Washington's the most important place on the planet. Of
course it is.
Okay, yeah. So
just ask them.
Just ask them; they'll tell you. Yeah. So as it turned out, that movie was a sense of, again, like Alien, a sense of, we're coming to take over. Yeah. And, Alien didn't. They wanted to just be left alone, but we went there and they said, stay out by eating our brains. These guys came here and said, we're going to kill you and take over. And we don't care. You're ants to us. Okay. So every movie has its own message. Then, of course, we have this.
Oh.
Close Encounters of the Third Kind.
That's a great one.
The extended edition. Okay. And this movie was fantastic and had a lot of very interesting messages. The messages were the aliens wanted to understand us, and they borrowed some of us for a period of time, but they brought them back, So was it really kidnapping? I don't think anybody charged them with kidnapping.
I say yes, though. But
right. Yeah. I mean, well, if it took me, I think I'd want to come home right away.
Yeah.
And of course, in that movie, we were treated to J. Allen Hynek, who was the father of modern ufology. That was his cameo. He appeared for approximately 3 seconds in the whole movie. Very nice. So the question is, what did government do? They didn't have a direct influence, perhaps, on each of these movies, but what they did was they probably talked to the producers and said, hey, tell us what this movie E.T. is going to be about. That's a nice, wholesome message. And then they decided to go non-linear with Alien and, Independence Day or whatever. But did TV shows and movies, does that have any influence on how we appreciate or not appreciate aliens? You betcha.
Well, look at nowadays. It's so changed the last 2 years or so. There's so many commercials with aliens and beaming things up and traveling on the moon, riding around. It's definitely a lot more now than ever that I've seen.
That is correct. That is correct. And this is exactly the kind of thing that we would want to see, is that people in general are getting more used to the notion that aliens exist.
Yeah.
Not
so scary.
No. And this is perfect, because when I do my when I lead into the rest of this talk, we're going to talk about not only do they exist, but how they can be here in short order. Okay. Yeah. Even from many light years away. Right. So
I'm looking forward to that.
Yeah.
That almost seems impossible too.
It does, but I don't think it is, So now we have to ask the question, well, why here? Okay. Why is Earth so visible to alien life? Okay. Well, it's actually quite a simple answer. I mean, we look at Earth as a little blue dot. You may not see it, but that's Saturn. That's a real picture of Saturn taken by Cassini.
Wow.
And here is Earth, our pale blue dot. Now, Carl Sagan, my favorite astronomer, said, "We are a pale blue dot in the universe. Our planet, our Earth." Okay, and that stuck with me, because he was right. Pale blue dot. However, that pale blue dot has been sending out a very important signal for several billion years. That would be that'd be very attractive to aliens looking for another place they may call home or go visit to explore. And that's especially if they're carbon-based beings like we are.
Oh.
Carbon-based beings like we are require oxygen to survive. We require this oxygen in order to work on creating energy within our tissues, and making glucose and sugar, right? I think that's kind of important, right? Because C6H12O6, there are 6 oxygens attached to that sugar molecule, and it's very important that we use oxygen in our tissues to have the life-giving energy. That said, our
deep breath.
planet, but
deep breath, everyone.
That's right, deep breath. See this right here?
Mm-hmm.
Oxygen buildup began in our atmosphere over 2.5 billion years ago.
Wow.
That's giga is the G there. Giga, giga years ago. Abbreviation. That's billion. So 2.5 billion years ago, oxygen started forming on our planet. But wait, where'd it come from? Well, back then, it was raining continuously on this planet, and the water was rushing off the land into the low spots, making big puddles. Those big puddles became what we call
oceans. Okay, it's not a trick question.
Ocean's 11. No, it's not. These became oceans, right? And why they're salty has to do with how sodium and chlorine atoms act when water is striking the rock strata. Chlorine atoms are easily detached, as are sodium, so you end up with these free elements rolling around in the water that's washing off of land masses. And it turns out that chlorine needs an electron and sodium has one to give. So they bond, and that forms salt, NaCl. Sodium is Na, chlorine is Cl.
Okay.
And that's sodium chloride. And so now that's why our oceans are salty. And when we as an evolutionary species emerged from the ocean, okay, we took with us the ocean in a vestigial manner. It's within our tissues. Yeah. This is our epithelial, our exoskeletal, or endo. Well, I forget what you call it all of a sudden. Holy cow! Brain fart.
Epidermis.
Thank you. Our epidermal layers in the skin. Thank you. I don't know why I didn't know that. My head was swimming around. Okay, our skin is an organ, and that organ contains within it a vestigial ocean. It has salinity, not nearly as much as the ocean, only a few percent, but more than enough to show that we've had a long history with the little element sodium and chlorine in the ocean. So sodium chloride is a very important element or compound that we cannot live without. Okay. Wow. So back 2.5 billion years ago, when this started, it became the GOE, the Great Oxidation Event, and it was actually rather rapid over which time it developed. So in an atmosphere, when you have all that oxygen in an atmosphere, the one thing it likes to do is leave the atmosphere and bond with something. And it wants to run into the ground. It wants to connect with all the other compounds and become a new element. So it bonds with iron very nicely.
Rust?
That's right. That's exactly right. And rust is 2 irons, Fe2, okay, Fe with a little 2, and then O3, 3 oxygens. So Fe2O3 is traditional rust. And on the planet Mars, which used to have a much heavier atmosphere with a lot of water vapor in it, when the H2O in Mars got disassociated by the ultraviolet radiation that was striking Mars, the O2, the 2 oxygens, okay, it's H2O, not O2. The H2O, the 2 oxygens dove into the ground. The hydrogen got lost to space, and the oxygen bonded with the iron compounds in the Martian surface.
Mm.
And so the Martian surface dust is rust, and that's why Mars is orange. It's as
Very
simple as
cool.
that, you know. And someone out there is going, "Wow, I didn't know."
Yeah.
Right?
I didn't know oxygen could dive.
Well, yeah. It's like, let's go, guys. Whoa.
Swan dive. Yes.
Yeah. So, yeah, Ronald says, I would hate the rain all the time. Yeah, I agree with you, Ronald.
Yeah, me too.
Yeah. But that's something that
But no
happens.
rain, no rainbows, right?
That's right. Well, no one was seeing back then anyway. Okay.
Yeah.
So that said, oxidation occurred quickly, and that buildup of oxygen was something that, if you think about it, an alien species looking elsewhere that maybe was, I don't know, a few billion years ahead of us, might be at the technology level at that time that it would have been able to see oxygen in an atmosphere. And as a cultural thing, they would have noticed, hey, if you actually look at the sky and see this planet here, let's follow this culturally for millennia, and they'll notice that the oxygen doesn't leave the atmosphere. Okay, it seems that the oxygen is being replenished by something. So if you have a lot of oxygen in an atmosphere, it can be created by geological processes, for instance. Well, if you have a lot of oxygen, then you might find that oxygen would dive into the crust, form oxides with other compounds and so forth. And then it would deplete the oxygen in the atmosphere long term.
Okay.
Well, we haven't been depleted. We've actually stayed pretty high. So this means that the high concentration of oxygen in our atmosphere is probably there because something's replenishing it. And an alien species would also say that. And if they're carbon-based, they'd say, well, the only thing that can be replenishing oxygen to this extent is other life. Ooh, I think we found a place where there might be life. And then they're going to come here. And because we've been sending this signal out for over 2 billion years, it means that the signal of oxygen in this tiny blue marbles atmosphere has been sent out over 2 billion light years. So that's way bigger than our galaxy and the local galaxies around us. Okay, it's actually bigger than the galaxy clusters near us beyond our own. So it literally is a good fraction of the size of the universe. So when you think about it, we've had plenty of visibility in the universe. I know that we know Stephen Hawking said we have to keep our heads down, got to hide from the aliens. Exactly right, Tara.
Too late.
Too late. We've been exposed. So yeah, and the oxygen was primarily from photosynthetic organisms, blue-green algae, plankton in our oceans that generated this, and it's really the waste product of plankton. So you're actually you live because of plankton poop.
Nice.
Yeah.
I thought we were stardust, not plankton poop.
We are stardust.
Who knew?
Yeah, but that song wouldn't sell. We are plankton poop, Nah,
I don't think so.
Yeah. Arista Records? Yeah, no. No. We'll pass. Oh, come on. It's a good song. It's true, but it's no fun, okay? So the James Webb Space Telescope is looking for oxygen indirectly in atmospheres because when oxygen is in an atmosphere, we can see its spectra. The only problem is the spectrum is, when you break up the light, you can see dark lines which indicate what elements are in the spectrum or in its light or it's composed of. And oxygen, the lines of oxygen, well, those are in the visible part of the spectrum. I've seen them with our telescope. I've got a spectral filter that we're going to be putting on our new SkyTour Benson telescope, and you're going to be able to see these different lines in the spectrum of a star, and you might see some light pollution of the spectra caused by the atmosphere itself.
Wow.
And that's something we want to avoid. But the James Webb is not going to be able to see the visible lines of spectrum lines from oxygen, but it's going to look for collisions between oxygen atoms. When oxygen atoms collide, they leave a spectral signature that's in the infrared where the James Webb can see.
Wow.
So if there's a lot of those collisional events seen, that's going to give us an idea of how much oxygen is in the planet's atmosphere. That's cool.
Amazing. Very cool.
So I see we have like a couple of minutes before the break, right?
We're like 7 about.
Okay.
Like, yeah, 6. Mm-hmm.
All right. Well, let's look in the chat and see if anyone's got any questions. I'm going to bring up this one here because this is Michael's Asylum. He says Mars doesn't look orange from the surface when you remove NASA's filters. Actually, it does, Michael. I'm sorry. Mars has a salmon colored sky. And sometimes when they use filters, the filters actually make the sky look blue. But here's something for you. At sunset on Mars, do you know what the sunset colors are? In actuality, the colors are blue. The sunset looks blue on Mars. Okay.
There's no atmosphere. Is that why?
Yeah, there is. It's 98% carbon dioxide. So it's only carbon dioxide, and it's thin. And it's got all these dust particles that are in it. So it's actually pretty interesting coloring. But the color of Mars is actually, in reality, is pretty much the same everywhere. You have this light dust on the surface of Mars, which is as light as talcum powder. And when that gets blown into the air, and it takes quite a considerable breeze to start accelerating talcum powder sized grains on Mars into the atmosphere. Okay. So you're looking at winds of about 100 miles an hour to actually start lifting talcum powder off the surface of Mars.
That is considerable.
The Martian surface, and you wouldn't even notice if you're being hit by that kind of wind. You wouldn't feel it because there's not a lot of molecules striking you. Okay. So I would say that when you look at the surface, it is a reddish hue because of the oxides that are on the surface. And that's a very thin layer. If you wipe those away, you actually see a darker brown and sometimes blackish looking underlying strata, because that is surface dust on Mars, and that gets blown around in the Martian dust storms. Even amateurs have photographed Martian dust storms, and you just see an orange ball, no detail on the surface, and that's because the dust is now airborne, and it takes months and months and months for these global dust storms to subside. So there you go, Mike. I just thought
very cool.
Mention that to you. So I want to see what else was in here, because let's see. Charles Smart, our friend Charles, says, but Mars still looks red in telescopes and to the naked eye. Absolutely correct. Mars is red because it is it's actually a rusted planet, unfortunately. Do
you think it squeaks with all that rust?
I don't know, but I have a feeling it'd run away if you brought WD-40 down.
Away.
Yeah. OG Skywatch, a good friend of SkyTour LiveStream, says, so logically aliens could send AI probes capable of light speed out to inspect and take sample if possible. Yeah, that's that particular process is known as von Neumann probes, and in part because what they could do is they can also fix themselves and make new copies of themselves out of raw materials they find as resources. And so that is possible, yes. In fact, it's very possible that the creatures people report as gray aliens might also be AI. And I think they might be biological robots, frankly. They could be biological robots. And I think that's very, very, possible,
Yeah, you hear a lot of that.
Yeah. And I just want to mention this because this is hilarious. We have great people. We breathe plankton poo from all across our ocean blue. Genghis, I love it. You're a superstar, Genghis. Thanks, man. That's really funny. Yeah, no, we have a lot of good people.
That's funny.
So Carl Becker asks a very good question. So movies and TV show bipedal aliens mostly. What would the actual odds be? Excellent question, Carl. Yeah. This is a very good question. And here's where I come down on that. Bipedal aliens are shown because on our planet, higher intelligence was naturally selected to walk upright. Walking upright gives you more visibility. Walking upright gives you the capability to reach higher into trees for things. It gives you the ability to develop hands with opposable thumbs where you can then grasp things while also climbing with your feet, hand over hand. It allows you to do all of these things. And I think that the bipedal nature is not necessary for intelligence. Okay. It depends on the niche they occupy in their evolutionary place on their planet. Okay. On our planet, for instance, the octopus is highly intelligent, and the octopus has 8 arms, each of which have a brain of sorts. Okay. So the octopus has many brains, and they can observe and repeat behaviors they view with their eyes. Yeah, that's been proven with a test, which I've talked about before.
So cool.
It is very cool. I think they're the most intelligent animal in the ocean. Yeah. And these guys are so smart that many people say they were aliens transported here. I can't say that's not true, but we can also see through their lineage, we can see all the way back to other mollusca in that family that they've been here for quite a while. So I don't know what the story is, where they come from, but I think they probably originate from here.
Cool. Hey, it's break time, Mark.
I know. So when we come back, we're going to talk about leveraging technology to go interstellar. All right. We'll be right back. This is SkyTour Radio. That's Tara down there. I'm whoever I am, but we'll be back in a minute.
Hey members, the new KGRA DB app is now available on iOS and Android devices. Gain on-demand access to any KGRA DB programming. Download any show directly to your mobile device to listen or watch on the go. Go to the App Store and search KGRA DB.
As UFO reports come in from around the world, the Mutual UFO Network, MUFON, is there. We continue to explore new cases and build our massive database. We share our information with the world in a number of ways. If you'd like to be part of our investigative team, you are always welcome. What could be more exciting than exploring the UFO question firsthand? Join MUFON, find your friends.
You're listening to the KGRA Digital Broadcasting Network. We provide unparalleled coverage of trending news in the world of ufology, cryptozoology, and paranormal phenomenon. Whether you're watching our video live stream or listening to one of our audio programs, You are getting the best from world-renowned researchers and hosts, guiding you through topics the mainstream won't touch. Miss one of your favorite programs? No problem. Head over to the members area at kgradb.com for access to our massive library of award-winning content. Make contact, stay connected, only at kgradb.com.
Welcome back, everybody. During the break, Tara was holding up something which looked rather interesting. I want to see that again. Will you please grab that?
I was hiking and I saw this rock and it looked like an alien face. So I painted what I saw in the rock. And those are the natural contours of the rock, these eyes.
Oh, wow.
Isn't that strange?
That is very cool.
But this is the first layer of paint. I still have work to do, so it's in progress.
Wow,
Isn't that wild, though?
Yeah. Is it a flat rock or is it more?
It's a flat rock.
Well,
it was just laying on the ground with this side up and looking up at me when I was hiking, and I saw a face. So I brought it home and put the paint on it to push the face out. It's pretty creepy.
It almost looks like a piece of shale.
Oh, it does, doesn't it?
Yeah, no, I'm not sure. Well, anyway, that's a cool
desert rock. So
that's neat. At first, when you held it up, I wasn't sure what it was.
Yeah, it's weird. It's weird.
Yeah.
It's fun.
Yeah, you know, people love what you did. People like your, people like it.
Yeah, it's fun. Well, you just that parabolia, how we see things in skies or nebula.
I like Charles Smarr's response. Australopithecus spacey.
Yeah.
Remember? Because our Lucy was Australopithecus afarensis, right? So Australopithecus spacey. Well done, Charles.
That's funny. It kind of does look apish, sort of. Yeah.
Yeah, no, that's pretty cool. I mean, I can see an elongated head in there too, kind of a thing.
Yeah, reptilianish. Yeah.
Yeah. So we left off. We're talking about our, what tech could an alien race leverage for interstellar travel, and I think it's important to think about the fact that, not everything is chemical rockets. Not everything is going to be just fire a rocket and blast a hole in the sky, depleting ozone and destroying our home a little bit at a time to get to space. We don't have to do that. Right now we do. And we've gone pretty fast with our rockets. Our rockets have gone quite fast. Okay. Event Horizon probe that went out to Pluto, it took 10 to 12 years to get there.
Wow.
And it was moving extremely fast. That is the fastest probe we've ever made. And if we sent it, go ahead.
Really? I didn't realize that. Okay.
And if we sent it to Alpha Centauri, the nearest star system, it would still take over 10,000 years to get there.
Oh, that's too long.
And it's fastest speed. Yeah, I'd have to go to the bathroom. I'd want to stop and get out and stretch my legs. Yeah, no, so that wouldn't work. So the bottom line is that we have to come up with something better, right? And that's the truth. So I want to discuss a little bit of quantum mechanics with everybody. And
cool.
Yeah, I'm not going to dive into things that are going to leave you in the dust. So don't run away. Okay. And so I just had to bring this up. Our friend Lubo, who is in China, he says this. He says that he sees my contour in that rock you held up.
Your face?
Thanks, Lubo.
Oh my goodness. We all see different things. It's all valid. That's why art, people respond to art differently because we all see it differently.
That's right.
It's all valid.
That's right. Okay. Curtis Horn says there is a company that's doing a slow way to orbit. I haven't talked about any of that, Curtis. So that could be a whole show in itself, I think.
That's interesting.
Yeah. And then, so talking about methodologies for going faster than we can go, that trip to Pluto would take 10,000 years if we were going to Alpha Centauri with that fast probe. There was another one that OG Skywatch, our friend, says. Well, that's Michael saying quantum mechanics headache time, but this here, a gravity drive that creates a warp bubble where time slows down the bubble, maybe down in the bubble. Yeah, that's actually the basis for Miguel Alcubierre's drive that he created in 1994. It was a thought problem, and he thought if you could use enough gravity or special matter, it needed something called negative mass, which doesn't exist yet. You could create a warp bubble around your ship, and that warp bubble would allow you to warp space, and thus you could travel to distant locations. At one of the calculations said using a Alcubierre drive, you can actually get to Alpha Centauri in as little as 5 days. Figure 2 weeks to be safe.
It might be traffic.
That's down from they're down from 10,000 years, so that's not a bad thought process. Charles also asked this good question: is there anything about the flight characteristics of UAPs that are reported that might hint at how they do it? I'm glad you're here, Charles, because that's what this talk is about. And you're going to see exactly what I'm talking about, because yes, there are, and I separate them out and show you these examples. Now, as an astronomer, I can tell you other things they could be, but we can't discount the possibility that we're seeing this other process in action. So as we look here, now we have to go into the quantum mechanical world. And when you look at what tech could an alien race leverage for interstellar travel, we have to consider that we might be leveraging the fundamental forces. Okay.
Yeah.
Now, the weak force is very important. The weak force is why you're here. This is the weak force is a force that is responsible for what's called beta decay. It's the reason why neutrons can turn into protons and travel up the periodic table. Okay. And that process is metered by what are called W and Z bosons, but don't even worry about the particles that are doing that. But those are forces, and the weak force is weaker than the strong force.
Strong force? Okay.
Yes, and the strong force is the most powerful force in the universe. However, it acts only over a very short distance, like the diameter of a proton. It doesn't really short. It's very small. That's
wow.
Correct. Yeah, it's very small. Yeah. So the strong force is what holds atomic nuclei together, because protons are +1 charge. And so if you put another proton next to it, like forces repel, right? 2 positive charges near each other repel. Okay. It's like having 2 north poles of a magnet, bringing them close to each other, and you can't touch them. They go past each other.
Push hard enough, you can.
Yeah. Yeah. As long as you can actually see that, as long as you can actually overcome that force, right? Well, overcoming that force is exactly what the strong force does. The strong force will hold protons together in an atomic nucleus. And there's a certain size nucleus beyond which you can't have a stable atom. That's about 118 protons. And as it turns out, our periodic table is 118 elements large. Beyond that, element 119, you might be able to make it briefly, but then it will just revert to element 118 as it'll decay and do other things. And that's the process the strong force is doing. It's actually holding the atoms together. So the strong and the weak force, you're here because of those. Electromagnetism, that's light. Did you know that light is an electric field and a magnetic field that are 90 degrees separate from each other? They're 90 degrees apart. They actually they're perpendicular to each other, traveling like this. That's what light is.
I did not know that.
Yeah, and that's why when you have a polarizer, which is got effectively like blinds moving in one direction or another,
Right.
that's why you can knock out some of that reflection. Okay, you still see light, but you're knocking out some of that light because you're getting rid of one of these components, and now you only get a little bit through. Think of it that way.
Interesting.
So,
okay.
yeah, so light is very important, but of these three forces we've talked about, the electromagnetic force, the strong force, and the weak force, every one of these can be discussed in terms of being either a wave or a particle. There's a duality. Electrons can be described with a wave equation. Okay. Light can be described as a photon, a particle of light, or a wave of light. Okay. We have infrared light waves, we have visible light waves, and we also have visible light photons. So there's duality in every one of these elemental forces, except for gravity thus far. Now, Einstein didn't think we'd ever see gravitational waves, and he was wrong.
We've seen them.
We've seen them.
One.
Well, we've seen lots of them when neutron stars collide or black holes merge. They make a ripple in space-time.
Cool
concept that people go, what the hell is that?
Yeah.
Okay. Space is a fabric. It's all connected. And so when you see a gravitational wave ripple through that fabric, it reaches us. Okay. And we see it. And there's detectors on our planet called LIGO detectors.
Oh, yeah.
And there's Virgo over in Italy. And that stands for Laser Interferometric Gravitational Wave Observatory, LIGO. There's one in Louisiana, and there's one in Washington, and there's one in Italy. So between these three, we can detect different times of approach of these gravitational waves. And from that, we can calculate where they're coming from and look for the source.
Neat.
Yeah. And so, all right, so we have gravitational waves. But what about gravitational particles? Oh, man, what about that? See, gravitational particles are things that we haven't seen. We haven't seen gravitational particles yet. And those are called gravitons in the parlance. Now, there are some theories as to whether these can exist, and I don't doubt that they do, right? And one of the things that we would do is dive into something called string theory to learn a little bit more about the possibilities. Okay. So in string theory, and you say, well, what is a string? Let's look at it this way. Okay. You have a proton, like I said, like a hydrogen is a proton and an electron. Okay. Big particle, tiny particle. Well, the proton is what we're looking at. Well, the proton is always moving. There's always vibration. This vibration is very interesting because when you stop it at this end, okay, and then you stop it at that end, what's in between is the path that it took.
Right.
And the energy along that path is what we're calling the string, effectively. Okay. So the infinitesimally small strings. Okay. And that, if you think of particles that way, then a whole new world of possibilities opens up to you. You get opened up to things called membranes. Our X, Y, and Z moving through time are 4 dimensions, right? These are considered a home membrane in the string theory world. Okay. These are called brane worlds, BRANE. Okay. Not brain world. Okay. But that said, there is one variation of string theory called Randall-Sundrum 1. Okay. And this is the most exciting. And the reason it's exciting is because in Randall-Sundrum 1, let's just discuss how it's built. Okay. You have X, Y, and Z moving through time. That's our membrane.
Okay.
And then you have a 5th dimension. Okay. You have X, Y, Z in time. That's 4. And then you have a 5th dimension, and it actually has a name. It's called the bulk. Okay. And that is a very, and then you have the Planck membrane on the outside. The bulk is actually extremely warped. And that warped dimension is extremely warped. The more you go in it, the more warped it is. And what does that mean to you? It means that as you go into the bulk, the universe starts to compact and get smaller and smaller around you. So if you can go really far into the bulk, then the universe is very close. So when you go into the bulk, if you travel 1 foot when you're this far into the bulk, that 1 foot can correspond when you come out to many light years. Okay.
Wow.
If you go in just a little bit, then that 1 foot might actually correspond to a foot or less. Okay. On the outside. So you can travel as far or as far or as close as you want to, if you can get yourself into that bulk.
Into that distorted
That
dimension.
Fifth dimension. It's exactly right.
Oh,
So how would one do that? Okay.
wow.
Well, I will tell you this. When we look at UFOs, and Charles, you'll be happy with me as we go along here, for your great question earlier. And by the way, Charles used caps because when I do my SkyTour live stream, I always ask people to put their questions in caps so we can see them and not lose them. So thank you for doing that, Charles. I saw your question very well. Thank you. When we look at UFOs, there's something to think about, right? First of all, UFOs are typically circular. Here's one. This is the S4 saucer. We make these at in my model shop. Okay, we've made probably 300 of these models for people. They love them. Okay, this particular saucer, notice its shape. They're either circular or they're triangular. I have a Belgian triangle up there too. We make, but think about this: circular or triangular. In a triangle, you can inscribe a circle as well. Now, why would I mention circularity? Why is that important? I think that UFOs are actually particle accelerators, and they're actually generating particles that leave the UFO and surround it and envelop it, right? And guess what? Those particles are a special kind of particle, and those special particles will take it into the bulk. Right, and we'll see what that means in just a bit. So the outer ring out here dispenses the particles, and the inner ring is safe for the occupants because they shield themselves in there. Now, we've seen in history people walking up to UFOs getting hit by radiation and coming away with radiation burns. Wow. So something's going on there. What would cause the radiation burns? Well, we hear that those ships are about 30 feet in diameter, and if they're particle accelerators, we compare them to our particle accelerators. We have huge accelerators miles around. This is a small one, but we actually cause the particles to go in a circle inside the particle accelerator by using massive magnetic fields to curve these charged particles around. Okay. When that happens, the particles emit a synchrotron radiation as they're being forced to move in a circle because they want to go in a straight line. You force them to go in a circle and you get this radiation. What happens when synchrotron radiation is emitted? That's dangerous to you. And so if you walk up to a ship that's emitting particles, all right, you're going to have synchrotron radiation coming out and hitting you to some extent anyway. They probably shield to somewhat. And then this particular central point is probably a shielded central core location where the occupants would ride, and where I'd want to be. Okay. But that's what happens. Those areas you're going to have synchrotron radiation. So that's a problem. But I think that they would have figured that out. An alien race would be smart enough to know that there's an issue, and they would have figured it out. So when we think about what particles they will create, there are certain particles that actually live in that fifth dimension effectively. And those particles are called Kaluza-Klein gravitons. Okay. Now, Kaluza-Klein gravitons have very special properties. They're 10 to the 16th times more powerful than our hypothetical gravitons that are holding us to our chairs right now.
Is that because of the dimension?
It has to do with the fundamental forces, and it has to do with the particles and the nature of the particle. And the Kaluza-Klein graviton is something that can be created in atomic collisions. And at least that's the thought. And what happens is when they're generated, there's a chance that they also can create micro black holes. Now, before you panic and say, oh no, they'll eat the Earth, keep in mind that micro black holes exist for only a few nanoseconds. They're gone. The bigger the black hole, the longer it can last. The smaller the black hole, the quicker it evaporates, because every black hole is evaporating. Every black hole. So When these KK gravitons are generated and surround the ship, like you see here, all around in a sheath, the first thing they do is create some micro black holes. And these micro black holes now are going to do several things. They're going to bark like a dog, which is probably your dog, Honey, I'm going to guess.
That's Odie, I think.
Oh, Odie, okay. Okay. The micro black holes are going to do several things. What they're going to do, number one, is they're going to absorb a couple of air molecules around them, probably. The next thing they're going to do is they're going to absorb any of the light that's being emitted by the unidentified flying object. Okay, so then they're going to also do another thing, the most important thing, and that is they're going to absorb the Earth gravitons, and they're going to prevent the gravity of the Earth from reaching this UFO. All right, and that's kind of the secret to how they work. Okay, so here's an image, and it has a UFO similar. Okay, this comes from Bob Schroeder's book, Solving the UFO Enigma. Bob's a good friend of mine, and this is all these things talk about KK gravitons. Some of this is based on his work. So the micro black holes almost decay immediately. That's how they actually work. Okay, and the only problem with this image is these black holes. This should be surrounded. They're not just on the bottom. They're all around here. Okay. So you have these gravitons and you have the micro black holes. They kind of mix together. So let's look at what happens. Okay. The micro black holes, as I said, they absorb the Earth gravitons. They are also making it so that the ship is not subject to Earth gravity because Earth gravity cannot reach the ship. Okay. This corresponds to reports of UFOs fluttering like leaves in the wind.
Yep.
Okay. There's no need for up or down. As long as you have your circular ship creating these particles, who cares if you're right side up or not?
Well, the occupants inside,
they don't notice anything because they're not feeling Earth gravity. They don't feel up or down. See, so they wouldn't care, and that's one of those things. They don't care how things look. We like aerodynamic and hydrodynamic things that go like a bullet. Well, that's because they're going through a medium. Well, we're moving the medium with these micro black holes, so we don't care, right? As aliens, we don't care. Okay, so the ship isn't subject to gravity. So what happens is these KK gravitons are actually particles that effectively live in the bulk. This fifth dimension. So as you generate them, your ship is pulled into that fifth dimension. And what happens then? What do it's as I said, it's highly warped. So distances are shortened in there. The farther in you go, 1 foot way far into the bulk will correspond to many light years, perhaps. Yeah. And 1 foot only a little bit into the bulk might correspond to a foot. And that could be like 1 inch. It doesn't have to be a foot. So clearly, the way they travel then is they don't even have engines. They don't need them. They just need a particle accelerator that can pull them in and out of the bulk. So generate gravitons around your ship, and in you go to the bulk, and then you have an entry point back into the 4 dimensions. That's the only thing we're not sure of how they would do that. But then once you have that entry point, you reduce the number of gravitons around your ship, and you come back into the 4 dimensions. So you don't travel from, say, here to here. You travel from here into the bulk, and then you're here. Or then you're here.
No strings attached.
No strings, and most effectively, no path to follow. So this means that if they want to just constantly oscillate back and forth between here and here, then they could pop out here and pop in here, okay, with no problem. Okay, and so if they do that, how might that be accomplished? They'd probably have to oscillate back and forth. So rapidly, with a frequency, go into the bulk and come into our 4 dimensions. So if they wanted to travel through our sky, and when you see something travel through the sky that's a UFO, sometimes it travels in a regular line to your eye, and sometimes it goes fast, and sometimes you see 90-degree turns and all kinds of strange motion. The occupants of the ship don't even feel any motion. Now, wait a minute. How could that be? Because they're popping out and popping in. So to them, they're just moving point to point to point to point to discrete locations and not traveling the distance between them. Our eye, our cameras, our sensors, all will make a line out of it because that's our experience. That's how our systems work. They say if it's here and then it's here, there's a line between there. It must have gone from here to here. All right. And if they're traveling if they're popping out and in only a foot away from where they were last time, overall, they're going to go from here to here to here to here to here, which on a camera would look like a line, on a sensor would look like a line, on a sonar underwater would look like a line. But if they're doing this oscillation back and forth, then they're neither here or there. So they could be deep under the water, right? Deep under the water and not feel the forces of the water because they're not really there. They're only there for a split second, and then, they're back. And that's something that means they could live in the deep ocean ad infinitum as long as their accelerator continued to pump out those beautiful little particles.
So how can you pop in briefly and not get crushed by the warped space of that fifth dimension? I mean, how is that possible to move within that? And I guess on that, I guess this particle accelerator, is that steerable? Or is it just they're just happen to be popping here and there? It seems like there's directional or intention to their movement.
Yeah, there's more to this that none of us understand, and that is, that this ship would actually have some type of directional capability. They would be able to steer where they're going to come back into the 4 dimensions. But keep in mind, these are exit points out of the 4 dimensions into the 5th, and entry points back into the 4 dimensions. So they're exits and entry points. That's all they are.
Okay.
They're not paths. So what they'll do is they will just pop in and pop out, and because they know where they're popping into when they come back into the 4 dimensions, I think this process would make them the greatest cartographers in the universe. They're map makers. They'd be the greatest map makers there is. Okay. Charles says it right. No inertia or momentum. Absolutely correct, Charles. There will be no inertia and no momentum because they're not really moving anywhere. It's as if they pop into a dimension and slide the Earth around to a different spot, and then they pop into it. See, so they don't feel anything. They could be standing on their head, sitting on a roller skate, and nothing would happen because they feel nothing. Okay. And that's how this works so well. And that's why when you see them go at 90-degree angles in the sky, you say, that's impossible. Nothing could survive that. Well, you're right. Nothing could, not even them. But that's not how they work. They're actually just popping in and out. Okay. And the question is, how would they, and this is a good question by Michael, how would they determine the proper point in space to exit the bulk to get to the desired location?
Right.
That's a question we don't have an answer to, Michael, because you're right. This is the thing which gives them the advance on us, because we don't understand entry and exit points into that 5th dimension at this point. We don't.
What about like crashed retrievals? Do you think that some people might understand that they're working on it? Because it seems like if there is real crashed retrievals, and if this is that, you would think somebody's working on this somewhere.
You would think that, and Ronald here asked a good question. Think about crashes. Now, people say, well, and if they're so advanced, why do they crash? I'll give you an example. Let's suppose you took an F-16 Fighting Falcon aircraft and you went back to times of ancient Babylon and flew over ancient Babylon. Holy cow. What would that look like? I can tell you what it would look like. It would look like your gods. In fact, and then what if you had a mechanical failure on the F-16? Well, we know F-16s have failures and can crash. Okay. So you'd crash. Oh no. The F-16 crashed, the Babylonians would say. Our gods bleed? What's going on here? How could they crash if they're gods? We wouldn't understand it, but you see, it's a sliding window of technology that gives you different expectations of your gods. So an alien race to us is so far advanced, how could they possibly crash? Just like an F-16 in the ancient times of Babylon would be so advanced to them, how could it crash? But we know it does, because that's something that came from our time. We can't even fathom how these guys might actually be built and how their accelerators in here would actually work. So how would we know? But they are fallible. They're not infallible. They make mistakes. When they land and get out and take people, abduct them, if that's happening, right? They stop this flow of particles, and they'll bring them down. The Earth gravitons will slowly bring them down if they start metering the particles away slowly, and then they can get out. this accelerator is shut off. They can get out, move around, do what they got to do, get back in.
Cool.
And I can tell you, in that point where they're not oscillating back and forth into the bulk and back, they're vulnerable. And if you hit them with a missile, they probably come down. So it's possible that we brought them down. It's possible that they just had a mechanical failure.
Yeah.
Because they are not infallible. Ronald, that's a great question. Thank you.
Mm-hmm.
You know, so if you think about it now, so what does this mean? What does this actually mean? Now, does it mean that creatures like this then are just, going to be running rampant on our planet? All right. Well, I don't think so. I think that every civilization out there will go through their nuclear phase, right, Tara? The nuclear phase, we're in it now.
Yeah.
In fact, we use a combination of fission and fusion to create nuclear bombs, thermonuclear weapons. So alien species coming here would notice that and want to know what's going on. Why are they doing that? Let's see how far along they are. Because I think there's scientists who came here because of the oxygen, not to steal it, but because it's a clue that there's other life here and they want to explore life like we want to find life. That's what we're doing too.
Yeah.
Okay. So in this way, if they're here and just oscillating back and forth between the 4 dimensions and the bulk, they're neither here nor there. And so they could live in the deep ocean for an extended period of time with no problem, because there's no reason for them to be on the surface. They can live down there because they're not feeling the forces of the water. They're not feeling the forces in the air. And so they can bounce around with impunity. And our Navy has the edict to actually observe and report these things. I witnessed one on a submarine at sea when I was a guest on the boat. And this is submarines are called boats, and surface warships are called ships. Yes, that's right.
Oh, okay. It sounds funny. It sounds like a boat sounds so much smaller than a boat.
I know. Yeah.
Sorry.
So to Charles's point way before, hello, Marianne is here too. To Charles's point before, okay, I wanted to just mention as well that we see reported visual effects, okay? We see UFOs changing colors and shimmering.
Right.
That is, the black holes, the micro black holes that we see here, okay, there, okay, are actually absorbing a little bit of light, causing the image to be distorted and maybe even change colors as the frequency is being shifted. So yes, we see that, and it'll change color and shimmer. We see them fading in and out as they put more micro black holes, more Kaluza-Klein gravitons around them. They are going to just literally disappear right before your eyes. And if they bring them back, then they will come back. Okay, if they reduce them, they'll come back. So yes, fading in and out. Check. UFOs, changing colors and shimmering. Check. Overtly vanishing, only to reappear somewhere else in the sky. Check. Now, let's talk about other things it could be.
Okay.
UFOs changing colors and shimmering, or any objects changing color and shimmering. We call that atmospheric scintillation. A bright star on the horizon will do that. It'll dance around, change colors. Sirius is famous for doing that. Sirius is famous for generating UFO reports. Fading in and out. Things that come and go in the threshold of your vision. Okay, yes. Overtly vanishing and reappearing elsewhere. The autokinetic effect, where you're staring at a dark sky and you see something in the sky, right, Tara? And the next thing you know, it looks like it's over here. It disappears, and then it looks like it's over there. In fact, it looks like that. But in fact, what it might be is just something moving through the sky and rotating and getting bright, dim, bright, dim. I did that test actually at a boot camp for MUFON, Mutual UFO Network. And I was able to show that everything that they were looking at in the sky, they saw this object here, then here, then here, then here. And they just pointed all these different locations. And they thought it was going ding, 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 ding. And they thought it was a UFO. Meanwhile, I was taking a photograph of it. And when I showed them the photograph, it was a dashed line, because it was a time exposure, nothing, dashed line, nothing. You know what that was? It was a ship doing, it was a rocket booster doing this, rotating. Here it was bright, there it was dim. Here it was bright, there it was dim. We call those tumblers. And so that's what they were seeing. But because of what's called the autokinetic effect, your eye has not evolved the need to be able to identify something. It's a point spot here, point spot there. It hasn't developed the need to track something in a blank sky. That's not what the eye is good at doing.
Right.
So that's why. So yes, but what we can't do is dismiss this potential here, the potential that we're looking at Kaluza-Klein gravitons in play, because that's what could be happening. We could be seeing that happening right now. So that, you see, is the important aspect of this. And so what's it mean? It means that UFOs travel by using extraordinary amounts of gravity. Okay. Very, very high gravitational fields are how they do this. These KK gravitons move them into the bulk. And because they only live for a split, a fraction of a nanosecond or a couple nanoseconds, they don't have any actual impact on either the ship or the Earth, other than to eat a molecule or two and to disrupt the image of the ship to us and prevent Earth gravitons from, being reached or reaching the ship. Now, what happens is they keep a net number of these surrounding the ship. That's why there's always gravitons around the ship, because it's a net number, a net collection of them, and they only live a few nanoseconds. So that's it. A net volume, and then if they shut them off, then they can land and get out and do their things. Mm-hmm. But I think they use truly extensive and massive gravitational fields around their ships. Okay.
And they would be able to travel, I mean, because of what you said, just want to make sure I understand, they could travel anywhere in the universe or anywhere within a planet, within the atmosphere, or would that also be underground? Because there's been reports of UFOs going into mountains and things like that.
I've analyzed a lot of the cases of UFOs going into like Popocatépetl volcano, discovered that what appears to be a UFO going into Popocatépetl is actually a plane circling behind the volcano and landing at the airfield, which is just on the other side. Okay, but in line of sight distance, I should say. So, I think that's what I'm talking about there. I want to say hi to Mr. Django. He's in Belgium. He came by to say hi. Good evening. Nice to see you. Thanks for coming. Okay. Ralph Wooden, who's also, by the way, an excellent astrophotographer. Cool. He has, and KK gravitons don't interact with matter like us in the Earth. They do, Ralph, but only to the limited extent of their existence. So maybe a few molecules of the air might get absorbed by them, and they'll absorb some of the light and some of the gravitons coming from the Earth. So they do interact with, molecules, which is physical matter to some extent. But they're still evaporating at a high rate, and so they can't last. All right. But that's an excellent question. And so that's what's going on there. Now, the question of where they're hiding is another one. Now, where do you think they're hiding?
In the bulk?
Well, they oscillate back and forth, right? Mm-hmm. And if they head out into the bulk, maybe they could stay there. But I think there's equally there's some other considerations I haven't discussed, and that is that if they stay in the bulk is a very dangerous place. You got to know what the hell you're doing if you're going to stay in the bulk for any period of time. So the most likely they're oscillating so that they don't get destroyed in the bulk or destroyed here in our four dimensions. Okay, so it's kind of interesting to think about it. And if we could do a true physics class, I would be able to discuss this in more detail, but we're not going to go down that path because this is actually future physics anyway. We can't even prove yet that there's string theories in existence. Michio Kaku agrees that string theory is the only game in town, but I can tell you that there's no absolute proof that any of that is right at this point.
That we know of.
That's right. It's very theoretical, but it all makes sense when you consider everything from the shape of UFOs to the burns people get, synchrotron burns, to the way they operate and move in the sky. It all makes sense. Being underwater or in the sky, moving what seems to be impossibly fast and not leaving a sonic boom behind.
Mark, so what do you think about the UFOs that have different shapes, like the Tic Tac? Could there still be, does a particle accelerator necessarily have to be round. You know,
If
it can be controlled by magnets, can it be any shape?
Well, there are linear accelerators, but I think circular accelerators are what we think we see here. Okay, but can you take a Tic Tac, which is a capsule, turn it on end, and look down its cross section? Guess what? It's round, right?
Oh,
It's
that's
just
true.
longer. Okay, so
Yeah.
it could have an accelerator that way too. So, and again, remember, there's no direction. So if it's horizontal, that's how it works. So Greg O'Brien says, why is everything round and spinning? It doesn't. You see, in the Earth versus the flying saucers, these were spinning. Okay, but there's no reason why they have to spin. These round shape is simply because that's a convenient shape, and it's a minimal surface to enclose your particle accelerator. When they're made tapered, that's because the particle accelerator can be in the outer ring. It doesn't have to be thick, Right. And again, they've got perhaps 1,000 or more years on us, minimally. So they've been able to make these accelerators and with extreme proficiency. So they've gone past a lot of the giant, bulky magnetic coils that we might use, and they're at a whole different level. And those are, again, very good questions. I can't even get to all the questions. There's so many good ones. So that's what I think about that. But let's move on to where I think they're hiding, and we're going to kind of run through this pretty quick. We've talked about the moon. Could they be in the dark side of the moon? Is the moon hollow? Well, no. If you go to look at the Apollo missions, you'll find that they left seismometers on the moon, and when stages of the Apollos, the stage that contained the lunar module, was intentionally crashed into the moon, they vibrated the moon, and somebody very wrongly said it rings like a bell, and that made people think bells are hollow. No, that's not what it was. Okay. That was a misnomer. I'll tell you why. Because if the moon was hollow, it doesn't have any openings on it like a bell has. A bell has a massive opening at one side or another, or many smaller openings. The moon doesn't have anything like that. Okay. If it did, it would have to be filled with air, because any sound wave wouldn't travel through a vacuum. So it'd have to have air in there. So right away that negates that possibility. But it's a standing wave in air set up through the hollow chamber of the bell that then comes out of the opening amplified, which is why we hear a bell ring. And so why would the moon what do they mean by ring like a bell? It meant that these seismic waves were going down through the moon, hitting the other side, and coming back and reflecting back from the inside surface and going bang till it damped out. Why is that? That's because the moon is nearly solid. That's why it did this. And if you go to Pennsylvania, to Ringing Rocks State Park,
I've heard of that.
Yep, you can go there and you can find rocks that you hit with a hammer, and they ring forever because they're solid, and they're almost the same structure throughout. But here's what I'm going to leave you with. If you go look at the Google LRO Quick Map, look that up, and you can explore the moon. I've just probably caused some divorces, because people are going to go here and they're going to spend hours looking at the Apollo landing sites, look at the tracks left by the astronauts and the rovers, look at the experiments on the surface of the moon left at Apollos 11 through 17. It's absolutely incredible. So I have a feeling you guys are going to really enjoy that. So let me know what you think of that. That was the talk that it was actually given some very nice kudos. I did it in Edinburgh, Texas, and Cowboy in his hat and boots, he gave me his cowboy hat. I mean, a hat and the boots are the most important thing to a cowboy, along with his horse. And he gave me his hat because he felt that this really finished the entire equation for him. And it kind of does. It kind of does. And I was really pleased that he was able to see that. All right. So the next thing I want to do for you now is I want to show you the next phase of SkyTour LiveStream. SkyTour LiveStream is these observatories that we have, and thanks to one of our two of our volunteers, one was named Robin, and the other one is Isabella, who is in the chat tonight. And you better show her some love, because this woman went and cataloged every observation we've had for 4 years, going on, well, 3 full years plus 2024. And so we can go back and literally search anywhere through all of our observations and get all the data where it was in the sky, notes about it, the type, how many images made up this particular stack. We stack our images together like image sandwiches. And guess what? This is going to be an Apple and Android app. And we're testing it right now. And I have to say, absolutely incredible. Let's show you what it is. Okay, here's the Helix Nebula. Okay, it's known as the Helix Nebula. You see that right there. And then you see it's also known as NGC 7293, Caldwell 63. There's other names for it. What is it? It's a PN, a planetary nebula. Okay, it's in the constellation Aquarius. We did a 35-second set of exposures on 400 gain. These are the parameters of the camera. And we did 20 exposures. Here's the location. And there's actually more out here. Okay, but if we go into it now, we can now say, well, what's it actually look like? And we can go view the image. And so this is the image we actually took. All right. Boom. There it is.
Ooh, pretty.
That is the exact image from that one set of observations we made. There it is. See that?
Beautiful, beautiful. It's eyeball.
Yeah. The eye of Sauron, right? So what this tells us is that we now have a database to go and look for all of our images, all of the many photos we've taken over the years.
Fantastic.
And you can do real science now, because you could search for all of the times that we actually I don't want to be here, sorry. We can search for all of the instances, for instance, of this. You can go to these filters, you can say type of object, and we're going to have instructions for all this, as a matter of fact. You could say emission nebula, EN, okay? And then you can say, well as dark nebula. And now you're going to get emission nebulae and dark nebulae, right? And it shows you these things. And so you click on them, right? And when you click on these, you come here and you can also now go view this image, right? And again, there it is. There's the Orion Nebula. Wonderful. With the Running Man Nebula. And you can zoom in, you can enjoy it, check it out. You can download it. And these are all the images that we give you free anyway, but you can now get them in a clearinghouse, a location where it's all visible to you in a glance with a beautiful application. And this is something that I have been dying for, okay, for many years. So you can also say, oh, look, Black Eye Galaxy. What's that? Click on it, say view the image. All right. Now you view the image of the Black Eye Galaxy and it looks like this. Now this is a holder image and it'll get clear in just a second. Okay. So here it is. There's the Black Eye Galaxy.
Really cool.
Because
it's got a shiner.
It has a shiner. That's why it's called the Black Eye. That's right. You're right.
Mm-hmm.
So you see, and this is called the SkyTour LiveStream STLS Companion, and it'll be available. And right now, we're not planning on charging anything for it. We're thinking maybe we're going to offer it to anyone who wants to get it. They don't even have to be members of SkyTour LiveStream. So this, again, it's a compendium of every observation we've made with SkyTour LiveStream since 2021. So pretty good. So this is a neat little guy. And it goes on and on and on and on and on. You got many hundreds and hundreds and hundreds of observations. Well, many times they're the same object, but then again, that's where the value is. When you look at something, for instance, if you want to look for changes, okay, and Isabella did this. She found asteroids. She found asteroids in our data. She found stars that are missing.
Pretty amazing.
From the last time the photos were taken. Yeah. So there's a lot going on, you know, and I think that as such, we have, you know, we're going to be offering this as well. It'll be online for the PC. It's for the PC. It's for Mac, Android, Apple. It's not out yet,
Nice.
But we will make it available for the PC and Mac before it's going to be an app that you can download on your phone. Okay. And that's only because it's very simple to do. And get this, it's dynamically updated. If we do a night of observing and you go to and you refresh this, you get the latest data.
Perfect.
Really cool. Yeah. So there you go. And so couple this with everything we've done. Okay. Like we also have mosaics in here. And these mosaics are different pieces of many that together would make up a nice image together. And we actually have the finished product that are up there as well. So you can get all those and you'll see the names and it tells you this is panel 2 of a giant dark band in the Milky Way. And it tells you what it is. It's really, really cool. So there's a lot going on. You want to see cool clusters. This is called the Wild Duck Measure 11. Okay, there it is. Right, and it'll get clear in a second. And here's dark nebula that is around it. It's that dark dust from whence we came. We were born in that dark dust. See, so pretty cool.
Very cool.
I hope you guys enjoyed tonight's SkyTour Radio with Tara and I. I know that I had a lot to talk about tonight, and I apologize for talking all your ears off over there.
Very interesting, though, Mark. Very cool.
I hope so. I hope it's cool. And, you know, if you guys felt it was worth it, let me know. You can pass your comments along to me. You can find me at skytourlive.org. And actually, Tara's there too. This is our email, contact skytour@gmail.com. All right. And you can find Tara there. You can find me there. You can find Marianne there. All right. And if you want to go up another level, you can head to our portal at SkyTour LiveStream's portal, www.skytourlive.com or .org. You can find us at skytourlive.org as well. We are a 501c3 nonprofit. So join our Patreon, if you will. You can you get a lot out of it. Okay. Maybe there's going to be some additional benefits we'll give you through this application. If you're in our Patreon, that's something we're working on as well. Show your love to the authors, Robin and Isabella, and let us take our leave. I think we're pretty close, aren't we?
1 minute, I believe.
Yeah, 1 minute to go. Maybe we have time for one more question if anyone's got a question. Of course, we have Marianne who's going to say that she's a little bit, she's a little too involved,
Yeah. Here's a question. Here you go. The app will it only be available in America or also in Europe and the UK?
Well, actually, it was actually built in Bulgaria, so by Isabella, who lives in Bulgaria. So it's clearly going to be available everywhere. All right. So I don't see any reason why not. It's not anything that has that kind of limitation. There's no ITAR compliance required for this.
Thank goodness.
Yeah. Well, you know about ITAR compliance, right? Having worked in the Arizona legislature yourself, right?
No, that was probably after my time.
Okay. Yeah.
So
Andy Lino, another wonderful viewer. After we watch this again, sounds close to what other signs have said. So if you're inside, you'll feel no acceleration. Absolutely correct. If you're inside the ship, you won't feel any acceleration because you're just in, and then you're at a different location.
And no weightlessness.
Yeah, we don't understand how that can possibly be in our arrangement and the way we exist, because we're always in the 4 dimensions. We've never been oscillating back and forth between other dimensions. Go to the 5th dimension, and you could travel from here to Alpha Centauri in as little as 20 minutes, according to one physicist. And if we did that, all right, that would take us to that location in 20 minutes, and we wouldn't feel anything. We would just suddenly be there.
I'd feel very excited that I made it across the universe in 20 minutes.
Right? Yeah, well, that part of the universe.
Yeah, that's right. And Mark, we're out of time.
I know we are.
Darn it.
Curtis asked if we'll have an after show. I wish I could. I was going to stream tonight, but it looks cloudy out there, or else that would be the after show. But no, sorry about that. But I will be at Contact in the Desert, May 30th to June the 3rd, and I'll be doing this talk as well as others. So we'll see you guys later, and thank you so much for joining us. We really appreciate your attendance, and we love you all. Thank you, guys.
Bye, everyone. Take care.